Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Hello everybody and welcome. Thank you for joining this afternoon. Hopefully we're all full and ready to kick back into the sessions. This first session this afternoon, Hybrid PQC Digital Signatures and SSI. I'd like to introduce our presenter, Erik Hieta-aho, senior scientist at VTT, combining his PhD in mathematics with practical cryptography applications. Erik brings a unique perspective to post-quantum cryptography research at Finland's Research Center. So at that, I'll hand it over to you.
Great, thank you, and thanks for the organizers. It's been a great conference so far. I'm here to talk a bit of a different perspective, SSI and digital identity, digital credentials. And this project that I'll be talking about, it was me and my colleague Valtteri here. It was just the two of us, really. There's a few other components as well, and I'll talk about that a little bit later. But the main gist of it was really about, hopefully this thing works. Okay. So this was the project title, actually. It says Hybrid PQC Self-Sovereign Identity Stack. And that's actually a link, the PQC SSI. And in this project, we had this goal of adapting the cryptography that's used in what's called a self-sovereign identity stack. Now, what is that exactly? The next slide, I'll go into a little bit more detail about it. But the overall project focused on these digital credentials, and we actually had partners in Ohio, from my alma mater, Ohio University, that took part in this project, and that's where this cross-border portion comes from, and of course the hybrid PQC implementation. And so self-sovereign identities. And so the concept behind this is for the individual to have control over their identity, and by the manner of implementing what are called digital credentials. For example, these could be, say, you having your driver's license credential on your phone, or an e-passport credential, or another huge use case is university credentials, being able to show that you have a degree from some university directly on your phone. It makes for, say, possibility of transferring between universities, things like this, makes that practical and efficient. And so some of the use cases of practical context of implementations. Now, what's an SSI stack require? Well, you're going to have a wallet, an issuer, and verifier. This is kind of the software stack that we had to kind of adapt the cryptography of. And what we did was we actually supported an open source solution called WaltID. Anybody can download this WaltID system, and it's free to play with, just to work with it. And so we basically took a clone of that and adapted the crypto in it for PQC. And there's a reason for that. And I did include this brief slide about the PQC digital credentials, but we don't have to go over this. There's been a lot of discussion already. Andy gave a great description of the status of digital signatures. And there's a reason I mentioned this, and I'll probably bring it up a little bit later as well. But I'll just keep going. But the important thing is in terms of the security of these SSI stacks, and so the security is based around digital signatures. So implementations of signing and verifying these credentials is using these digital signature algorithms. And in Europe, there's a huge push for SSI to be distributed throughout all of Europe, and this EIDAS version 2 is actually put a timeline on the actual time, or a schedule for when the countries in Europe have to be able to provide a digital credential wallet to their constituents throughout the European Union. And I believe it was this year. I don't remember the exact deadline, and because it was also delayed somewhat. The issue was, and this came up when we were working on this project, is that there's no PQC discussion in this EIDAS regulation. And to us as cryptographers, especially in PQC, we're like, that seems crazy. And that's the other issue is in the European Union, things take time, a lot of time, especially going through the Commission to get things implemented throughout the European Union. I have a feeling the reason is that they didn't want to slow down the process of building up this ecosystem of EIDAS. And hopefully there will be updates to these requirements soon. I don't know, I don't have a timeline. I haven't even heard much discussion about it, so that's another issue. So it made our project all the more interesting and more like just fun, if anything, because it's also a very new ecosystem. There isn't any, there's no standards necessarily. So like, I did mention this EIDAS. This isn't even a standards. This is like the European Union kind of just putting out regulations, pushing to have a particular protocol implementation of these wallets throughout the Europe. But there still isn't official standards in this context. There was a good talk from ETSI earlier today that mentioned the, I forgot the acronym, but it's basically the digital wallet, the European digital wallet. And that's the same concept of this EIDAS. And in that ETSI talk, they mentioned that they're starting on standards with respect to adapting them to quantum safe protocols as well. But it's still like in draft form, essentially. Okay, hybrid cryptography. That's been also a hot topic throughout this conference. And I'm not saying that I'm fully advocating hybrid cryptography, but we thought it would be an interesting project. We are researchers. We wanted to see how the stack would work, what would be needed to adapt to have a hybrid algorithm to work in this context. And so in our project, we're considering hybrid as being an implementation of two digital signatures implemented in parallel. And specifically, we're talking about a classical and PQC, and we chose ECDSA and ML-DSA. So that's giving us this classical security of elliptic curve while also protecting for the future of quantum computing. And this is a little bit of a glimpse in terms of the implementation of the actual signature. And we chose this parallel version where we have non-separability, which essentially is saying that you have to verify both signatures when you go to signing or when you go to verifying your credentials. And meaning that if one fails, the other one still has to sign and to be verified fully. So basically, both have to be fully verified, or otherwise the credential will fail. Or in other words, it could be cracked, things like this. So there's a variety of reasons, of course, that we chose the algorithms we did. It was still this was a quick project. Officially, it was like 9 months, and we didn't really get into actual, I'd say, programming or adapting the cryptography until we probably had about 6 months that we actually got to work on it. So we just kind of chose ML-DSA because, well, it has relatively fast verification, and that's actually pretty important in this context of these wallets because you can show your credential and it'll verify quickly in the system wherever you're trying to show your credentials in whatever use case that you can work with. And ECDSA was actually is the typical algorithm that's already implemented in the context of these SSI wallets usually. Now, a little bit more into the details of the actual implementation. And I will say my colleague Valtteri was heavily the programmer in this project, so he has definitely the more technical details behind the implementation itself. But it was basically, we took what WaltID had and we're taking their cryptographic library and adapting it. So it was written in Kotlin and uses a JavaScript API, then with Bouncy Castle as the provider of the algorithms. So that's where we pulled the dilithium, or ML-DSA, and ECDSA. And so there were 3 relatively main tasks that needed to happen for this implementation. Implementing a Java security provider for hybrid signatures, implement the JOES specific functions, and integrating both into SSI specific logic. In other words, into the protocol that's required in the SSI stack. Excuse me. And of course, this is largely done in a test environment. It's essentially on my colleague's computer. Though we can implement it wherever we like. And that's also the nice thing of these open source tools. Well, you can basically download the verifier, issuer, and wallet and kind of work with it in your own context. Of course, if you wanted to actually use these in the real world context, we would need interoperability and wide adoption and standards, all of which are still very much up in the air, and none of them that exist, at least the protocols and common usage of SSI, none of it includes PQC yet, which is, again, worrisome. So, and it wasn't necessarily just a drop-in. That's the one thing that we realized, of course, is that you can't just, this is a bit towards the hybridness. Hybrid algorithms are pretty unique, and it wasn't just, you can't just drop it in to the particular context. And that's largely due with, well, there's no standards in the context of hybrid algorithms. And the, let's see. So SSI relying on this JOSE, or Jose, depends what, for cryptography. And there's still draft stage PQC standards, and also that's a little bit about what we're talking about in terms of ETSI. And that might have been written prior to the FIPS line. FIPS had come out to 03, 4, and 5. But there's still nothing about hybrid cryptography. So that was a little bit of why we wanted to test and work with it and see how it would play. And yeah, that's where the JOES library is only supporting standard signatures, of course. Crypto agility, that's a little bit of this idea of supporting the 2 types of signatures, and using a Java security API is useful, but attention should also be paid to application-specific code. And that's we had to actually do very specific adaptation of the code for the algorithm to be secure, to work. And the big notes, of course, in terms of PQC is that this signatures are much larger, like we've been seeing all day today. And it actually required changes to configuration of the database implementation. And of course, this is the drawbacks, a little bit of hybrid signatures, that they're just harder to implement rather than the PQC. And we state that because we actually implemented both. We have an implementation of the stack with just PQC, ML-DSA, and also the hybrid version as well. So there's flexibility in that context as well, depending on how the standards get created in the future. Performance, ML-DSA, mentioned already, verification very fast, so that's a very good thing. Key sizes is of course, the drawback. Public keys are very large, and you can see from here we got some numbers, a few numbers at least. But these DID identifiers and DID documents, these are kind of the tool that are used to basically where you store your public keys. And the way this SSI ecosystem works is that this is a decentralized identifier, this DID. And some of you might know how blockchain is very related in some context with SSI. That's because you can basically store these DID identifiers onto a blockchain into a public context, and that's where you can get your public key and verify these signatures are for your own identity type thing. So there's that context, but it's actually moved a bit where you don't have to have blockchain necessarily as your setting where you place or where you I don't know, broadcast the right word, but where you place your DID documents. So signature sizes, this is a little bit of a glimpse into the sizing differences. ECDSA, 66 bytes, and ML-DSA, 3 kilobytes, basically. And so that was the other argument we had was well, it's not really what's the difference of adding 66 bytes to when you have a 3,000 kilobyte size signature? It's not a huge overhead in that context. So in that sense, it made a little bit of sense to be able to do this implementation. And let's see. So that was really the nutshell of our project. That was how far we got in the 6 or 9 months of the project. There was a bit more to it, but in our future plans, we're hoping to benchmark other PQC algorithms. Now that we learned how to adapt this stack, I was considering maybe choosing some of the on-ramp digital signatures to see how they I don't know, I'm a coding theorist, so I would like to try one of the code-based ones just to see how big the actual signatures are and how they impact. But there's, of course, the variety of choices that are available still, 14 of them. That was why I had that list earlier, because that would be kind of where we would draw some of the other signatures and test them out and see how this works. It could be in the hybrid one, or we would just test it by itself. We'll see. There's a few other topics that, of course, come up in future work. This is related to another project, but it's still an SSI domain of having a machine-to-machine authentication flow in this context of SSI. We're in another project where I believe we have a partner that's actually implementing that, or they have plans to. And let's see, that's the other mention. It should be mentioned that our wallet and this Wallet ID technically is a web app. It's not like an application on your phone at this state, but it could be quite easily adapted to being an Android application, just if you have the time, really. And then zero knowledge proofs is another hot topic, especially in SSI. Another concept that doesn't have standards yet, but there is work being done in that domain as well. This was a brief slide about how we collaborated with Ohio University as well in this domain. They had an implementation of the SSI stack as well. This vcplayground.org, if you ever get into the domain of SSI, that website is super useful for interoperability and testing a variety of different verifiable credentials. So, and that's actually, it was super useful for our project as well. This is our funding organization, the grant that we won for this project, NGI Sargasso and the European Commission. And I wanted to mention this is another European project that we're a part of, actually prior to this whole hybrid algorithm, and it's called Tango. And it's another Horizon Europe project where there's implementations of zero knowledge proof being designed, and we're going to have pilots running on SSI with zero knowledge proofs. And there's a variety of concepts that are being implemented in this project as well. And this project is really how we ended up in the domain of SSI. So we had this knowledge built up, and we thought of, oh, let's make some PQC out of it too. So that was kind of the fun part of it. And yeah, that's a little bit of a brief description of the idea behind zero knowledge proofs, how these verifiable credentials can be actually formatted in a manner and with a structure so that you're able to restrict the access to information. You only basically have to show the exact information that you want when you're verifying your credential for a particular. For instance, if you want to show that you are older than 18, you can use credentials to basically only state that, yes, I'm older than 18, and it would just verify this, that your credential is accurate and this is a true statement, without necessarily giving away your birth date, for instance, or the year you were born. So that's one of the key examples of zero knowledge proof that is thrown around almost all the time. But that's pretty much all I had. Yep. And if there's any questions, feel free. And,
All right. Thank you so much, Erik. Appreciate it. So yeah, thank you. If anyone does have any questions, Mike is over there, so feel free to line up. And I don't know, Chris, if we have any online.
Hi, good presentation here. Two quick questions. So for SSI, what kind of identity credentials have you worked with? Is it more certificates, keys, tokens?
So they're essentially, what are they called? They actually have a formatting of their own as a JSON LD formatted credential. So I'm not sure if it's the same concept as a certificate, because it is somewhat different. I'm not entirely sure, to be honest. Yeah, sorry.
Yeah. And for the wallet, should we be thinking of an HSM potentially as a wallet?
Not in this context. This would be quite, as far as I understand, it would be essentially a app on your phone where you're storing. It's just an app where you can store your private keys on your say device or on.
It could be something much less weight than.
Yeah,
the
not
HSM.
necessarily like an HSM at all. It's much less. It's essentially like a normal app.
Very lightweight. Okay.
Yeah.
Thank you.
Yeah, definitely.
Thanks, Eric. So you mentioned that you implemented a Java security provider for this. Normally that would be an abstraction layer that gives you signature validation, signature generation. But you also said that there was a pitfall around having to modify application code around that on top of having implemented
This would
that.
be a question for Vault today.
Okay.
And he's probably asleep right now.
Gotcha.
It would definitely be on the more technical question.
Gotcha.
But, yeah, sorry.
Outside of that,
I can connect you though.
I'd love to
Yeah,
to
definitely.
connect. Any chance that y'all would also be open to contributing back to the open source community on something
Oh,
like
that's
that?
the plan.
Oh, nice.
Oh,
Perfect.
I guess I didn't mention that. The whole purpose was to support the open source. For instance, Vault ID. We actually reached out to them and we were like, "Are you guys interested in this PQC implementation?" And their response, what we got was like, "It's not on their radar." And I was like, "That's a little bit nerve-wracking," but yes, that's the intention,
Awesome.
definitely. So,
Perfect. All right, appreciate it.
definitely. Thanks.
Did we get no remote questions? All right, anybody else? All right, wonderful. Well, thank you so much. Appreciate
Thanks,
it again.
everyone.
At SSL.com, trust is what we do. We provide PKI solutions, identity trust services, and cloud code signing to keep your data and software secure. Secure documents at scale with high-volume document e-sealing. Join us at the PQC Conference 2025 to explore secure solutions. SSL.com. Securing trust, enabling innovation. Visit SSL.com.